Angles of elevation and depression. Our objective is to solve problems involving angles of elevation and depression. Who uses this? Pilots and air traffic controllers use angles of depression to calculate distances. Some vocabulary to know. An angle of elevation is the angle formed by a horizontal line and a line of sight to a point above the line. So notice here, angle 1 is an angle of elevation since the horizontal line is here and then the viewing angle is looking up. The angle of depression is the exact opposite. The angle of depression is the angle formed by a horizontal line and a line of sight to a point below the line. So angle 2 would be an angle of depression. Let's practice this. Classifying angles of elevation and depression. So let's look at angle 3. Angle 3, we have our horizontal going here, and our viewing angle, or viewing point, is below that. So angle 3 is an angle of depression. Angle 4, you have the horizontal line here, and angle 4 is viewing a point above this horizontal, so therefore it's an angle of elevation. And for angle 5, we have our horizontal here, and you're viewing a point below the horizontal, so angle 5 is an angle of depression. And angle 6. Our horizontal is here, and angle 6 is going above, so angle of elevation. The trick to dealing with elevation and depression is first look for where the horizontal line is for each angle you're looking at, and then look at the other side of the angle. Let's apply this. Finding distance by using angle of elevation. An air traffic controller at an airport sights a plane at an angle of elevation of 41 degrees. The pilot reports that the plane's altitude is 4,000 feet. What is the horizontal distance between the plane and the airport? Round to the nearest foot. Take a moment and draw this diagram below. Now that you've had a moment to draw the diagram below, you have your height is 4,000 feet, and we're trying to figure out how far the plane is from the airport, and it's looking here, and we've got a 41-degree angle. So you simply use your regular trigonometry for this. So you have opposite and adjacent, so you're going to use the tangent of 41 degrees is our opposite, so 4,000, over our adjacent, which is our unknown. So we do x is about equal to whatever 4,000 divided by the tangent of 41 is, and therefore x is about 4,601 feet. Try this next one on your own. Alright, now that you've had a chance to try it on your own, let's try it together. A forest ranger and a 90-foot observation tower sees a fire. So, they're in the 90-foot observation tower, that's where the 90 came from, sees a fire way over here. The angle of depression to the fire is 7 degrees. What is the horizontal distance between the tower and the fire? Well, since we have two horizontal lines, we know they're parallel. They're also marked as such. So alternate interior angles will give you that this angle over here must be 7 degrees as well. Alright, so now we can utilize our 7 degrees, our 90 feet, and our unknown. In this case, we've got opposite and adjacent, so we will use tangent. So we have the tangent of 7 degrees equals our opposite over our adjacent. So multiply by x, divide by tangent of 7, and x is 90 divided by the tangent of 7, which is about 733, and we're in feet, so 733 feet. So from the tower to the fire is 733 feet. Let's try another application. Take a moment and see if you can try this one on your own. Alright, now that you've had a moment to try this problem, let's see if we can figure it out together. A pilot flying at an altitude of 2.7 kilometers sights two control towers directly in front of her. The angle of depression to the base of one tower is 37 degrees. The angle of depression to the base of the other tower is 58 degrees. What is the distance between the two towers? Round to the nearest tenth of a kilometer. So we have our horizontal line, our plane is up here. So one tower, we can use alternate interior angles to get our 37 degrees. And we can use alternate interior angles to the other tower here, which would be 58, and then that makes this one 58. So if we can find our distance y and our distance z, then we can subtract them and get x. Since we can't just straight away find x, because we have to utilize a right triangle at this point. So why don't we start with our biggest one here, our z. So we have 37 degrees. We're dealing with our opposite and adjacent would be z. So we have the tangent of 37 degrees is 2.7 over our unknown. So when we solve for x, we multiply both sides by x and then divide by the tangent of 37. So x is 2.7 over the tangent of 37, which is about 3.6 kilometers. So z is about 3.6 kilometers. Well, let's try finding our y. So we're going to do or use 58 degrees, and we've got our opposite and our adjacent as the y. So we're going to use tangent again. So we have the tangent of 58 is equal to our 2.7 over our y. So now we solve for y. Multiply both sides by y and then divide by the tangent of 58. So y is equal to 2.7 over the tangent of 58, which will give us about 1.7 kilometers. So y is 1.7 kilometers. And now we just need to figure out x. Well, if we know that the total length is 3.6 and one of the pieces is 1.7, we can simply subtract the two and get our results. So 3.6 minus 1.7 gives us 1.9 kilometers. So the two towers are about 1.9 kilometers apart. And that concludes our lesson on angles of elevation and depression.